Hi everyone, so this is question 8 from tutorial sheet 3, and the question says evaluate each of the following using the Moivre's theorem, hence express your answer in the form x plus iy where possible. So I'll pick out some questions which seem to be difficult from this question. Those are the ones that I'm going to do. But if you have any questions on any of them that I'm going to leave out, you can still text me or inbox me on this line here on WhatsApp. Let us start. Question 1. It says z is equal to half plus half I, then to the power 5. So the first thing when answering such questions, remember what you said. You first have to convert these this complex number to polar form. So we convert this one by first finding the magnitude of this same complex number. So the magnitude of z, which is also sometimes called r, so the magnitude of z is sometimes called r, is equal to the square root of that, the square root of half, you square this, then plus half again squared. Then after finding the answers there, you discover that your answer will be, it's going to be the square root of 1 over 2. So this is going to be your answer. So this is going to be the magnitude of z. We move on to finding now the argument. So the argument of z, is simply the angle of z. It's going to be the tan inverse of this over that. So put half on top there, over another half down there. So when you divide these, you get your answer 1. So this is just the same as the tan inverse of, remember what you said, finding the argument of this is just y over x. That's the reason I've said half over half. So which is just going to give you the tan inverse of, so tan inverse of 1. So the tan inverse of 1, you get your answer to be 45 degrees. So to test where your complex number lies, this is imaginary, this is the imaginary axis, and then this one is the real axis x, and then you can plot this. In order to test, you plot this complex number, you test it. So it's going to be approximately half is going to be there, and then another half there, since both of them are positive. So I mean my complex number is going to be in this direction. It's going to pass through this point. Yeah. So from there, what you do is, since you know that this is your 45 now, this is your 45 degrees, you can now move on to writing it in there in the polar form, since it's in rectangular form. So you write it. So your z is equal to, your r is going to be this half, the square root of half. So we write r there, which is the square root of half. And then open brackets, cos 45, and minus plus sine 45. So sine 45. So from there we now, so this is our complex number, we now put this 5. So putting that 5 is just the same as doing this. And according to the rules of indices, this can also be written as half, the square root of half, and then in brackets like that, and then to the power 5, and then open brackets again, cos 45 plus I sine 45. So this is I sine 45. You close the brackets like that, then to the power 5 as well. So now we begin to solve the question. So half to the power 5, you are going to get your answer to be, so half times half, or the root of half times the root of half, you are going to have half, and then again the root of half times the root of half, there is half. So when you add the two, when you multiply the 2 and then multiply it by the remaining square root of half, the answer you get is 1/4. Let me first write the complex number here, is equal to 1/4, then the square root of half like that, then you open bracket. So what you do to this 5, you just multiply it with the angles there, so it will be cos this 5 times the angle there, so it's going to be 5 times 45, 5 times 45, then plus, so it's going to be plus, and then I sine, again you multiply the angle by 5, which is 5 times 45. Write it properly. Oh yeah, 5 times 45. So finally the answer we're going to have is 1/4 then the root of half, then open brackets, cos 5 times 45, you get your answer to be 225, then plus I sine 225 again. So this is going to be your answer for question 1. So this one here is a little bit straightforward, I would say so. Why? Because if you want to solve this one properly, you can first do what? You can first find the conjugate of this. You remember how we are simplifying complex numbers from previous videos? You find the conjugate of that and then multiply it both sides on top and down. Then after finding the final answer in the form x plus iy, then you come and multiply the angles. You convert it first to the polar form, and then you come and multiply the angles by 10. Then after multiplying the angles by 10, you add the, you raise the magnitude to the power 10, just like we did here in these questions. So the only secret part here is that you simplify the complex form that is inside there. Let it be in this form. Then you continue. Same applies to this one. Yeah, but if you want again another way of doing this, you can first find this on top there, and then you do it separately. Let me just demonstrate it this side. You can do this 1 plus the root of 3, there's I this side, then close brackets, to the power 10, and then again 1 minus I, the root of 3 to the power 10. So you do them separately like that. This one you pass through all these stages that we've made here. You also do the denominator there, you go through all these stages that we've done here. Then you come and divide them. I'll show you how to divide complex numbers. Let us first move. Let us move to this question. So this one is already in polar form. So what you do, this one is already in polar form. So this one is straightforward. Let me just do it very quickly. It's the root of 3 cos 2 pi over 9 minus the root of 3 sin 2 pi over 9 raised to the power 6. So it's cos z. This is question 4, I guess. Yeah. So z is equal to open brackets root 3 cos 2 pi over 9, and then plus the root of 3 sin 2 pi sin 2 pi over 9 to the power 6. Let me just confirm if what I've written is correct. The root of 3 2 pi over 9. Oh, there's a minus there. Okay, alright. So instead of putting a plus here, there's supposed to be a minus. Alright, there's supposed to be a minus there. So same thing, the same principles apply. First of all, you can factor out this root 3 here, or if you don't want to factor it out, you can leave it like this and just say z is equal to, So this root 3 to the power 6, the square root of 3 to the power 6, or maybe let's do it this way. Let's just factorize it out. It's going to be like this, then open brackets. This is going to be cos 2 pi over 9 minus I sine 2 pi over 9, like that, and then everything you put them in square brackets to the power 6. So this is how it's going to be. So we start again. You first start by raising this root 3 to the power 6. So the square root of 3 to the power 6, and then open brackets, then this cos, this theta you multiply it by 6, so it will be 6 multiplied by 2 pi over 9. Then minus I sine 2 pi over 9 times 6. This is supposed to be in curly brackets or square brackets if you want to call them that, like that. And then from there, what you do here is you work out now the question. So this is going to give us, so the root of 3 to the power 6 is just the same as root 3 times root 3 times root 3 up to you are multiplying 6 root 3's, and then you get something like 27, because 2 root 3's will give you 3, another 2 group of root 3's will give you 3, another 2 group of root 3's will give you 3. So meaning you are multiplying 3 3's, which gives you 25. Oh sorry, 27. And then you open the brackets like that, you write cos, and then 6 times this is going to give you 12 over 9. When reduced, it will give you 4 over 3. 4 over 3 pi, then minus I sine again you multiply 2 pi times 6 divided by 9, you get 4 over 3 pi again. Yeah, like that. So this is going to be your answer for question 4. This is going to be your answer. Let's move on to the next question. Yeah, so here we are. So if you have any challenges, I know maybe you might face challenges here or there in solving this question and that question. You can solve them somewhere on the separate paper, and then when you solve I mean question 2 and question 3, when you solve them, you can forward them to me on WhatsApp, and then I'll confirm if your answer is correct or wrong. That's what your friends are doing. Yeah, so if you've never done that, I can help you also in that way. Write it down, solve it, and then send it to me on WhatsApp. Or if I see that there are a lot of requests on from you guys that I should also solve this too, I'm going to make a separate video for just the 2 questions. But I guess they are straightforward. If you just know how to solve this one and this one, I think you're home and dry. It's easier. You're going to find the answers. All right, let's see this one. Let's check out this one. So for this question, when you look at it here, you can work out this one separately. Yeah, you also work out this one separately, and then you come and multiply them. Anyway, let's just solve it, and then we also do this one, then we are done for this question. So this one is cos pi over 9 and then plus I sine pi over 9 to the power 12, and then yeah, it goes on like that. So this side the only difference is pi over 6, 5, 2 and then 12. Okay, let me just write it. This question it's denoted as question 4. It's supposed to be question 5. So question 5 is z is equal to, open brackets, cos, so open brackets, cos pi over 9 so plus I sine pi over 9 to the power 12, then 2 cos pi over 6 plus I sine pi over 6 to the power 5. Let me check, let me just confirm. Alright, that's how it is. So from there we can go on now to start solving the question. So z is going to be, yeah, so here we don't have the magnitude here, the magnitude is 1, so we just go straight by multiplying this 12 times the argument that has been given there. So 12 times pi over 9, you get your answer to be, let me first write this, cos, so your answer will be 4 over 3 pi, then plus, you multiply this 12 times this angle again, you get the same 4 over 3, so to be sine 4 over 3 pi. Yes, like that. And then apart from this, we move on. We also open the brackets this side. I'll open curly brackets because I don't know how many brackets are needed inside. So 5, these 2 should be raised to the same power 5. So I'm going to raise this 2 to the power 5. And then I'll open the brackets. This cos, I'll write it there. And then this angle, we multiply it by 5. We are going to have 5 over 6 pi. 5 over 6 pi. Then plus I sine this angle again, you multiply it by 5, you get 5 over, so pi over 6 times 5, you get 5 over 6 pi, like that. Then you close the brackets. So we move on to another way. So here again they are testing us again on the addition of complex numbers. So when you're adding complex numbers, you simply multiply the magnitudes and then add the angles. When you're multiplying the complex numbers, two complex numbers, so we have this first one and this second one here. So what you do here, you just multiply the arguments there. You multiply you multiply the magnitudes. So 2 to the power 5 is 32. So you get 32 times this one here, the magnitude of this complex number is 1. So 1 times 32, you get 32 like that. And then open brackets, then cos, this is going to give you cos, and then you add the arguments there. So yeah, so even this one is straightforward, because you are just going to raise this 3 to the power 3, raise that 3 to the power 6, and then you divide them. Now since you are dividing two complex numbers, instead of adding the angles, you are going to subtract the angles. Anyway, let's do it. Yeah, so this is the question. So first of all, remember what I said, you raise this 3 to the power 3. So 3 to the power 3, you get your answer to be 3 to the power 3. Your answer is going to be 27. So you have 27, and then open brackets, cos, you multiply this 3 times 4 over 3, this 3 times 1 over, pi over 4, you get 3 over 4. You get 3 over 4 pi. And same applies to the second part this side. You multiply the argument with the power. So this 3 times the pi over 4, you get 3 pi. You get 3 pi over 4. So like that. Then divide by like this. Then this 3 to the power 6, you get so you get this is 729. You get 729. 3 to the power 6, you get 729, and then followed by this angle multiplied by 6, you get something like cos. This is going to be 6 times pi over 24. You get pi over 4, and then plus I sine pi over 4. So now we are dividing complex numbers, this into that. When you're dividing complex numbers, what you should put in mind is that you are going to divide the magnitudes of these complex numbers, and when you divide 27 by 729, your answer that will get to be 1 over 27. So you get 1 over 27 like that. So that is going to be your magnitude of the final answer, or the final complex number. Then you write cos there, cos. So what you do with the angles when you're dividing two complex numbers, you subtract the angles. So you're going to subtract 3 pi over 4 over, and then minus pi over 4. So 3 pi over 4 minus pi over 4, you get 2 pi over 4. So 2 pi over 4 is just the same as writing pi over 2, then plus I. Same applies to this second part here. You subtract the angles. So the angles that we're going to subtract 3 pi over 4 minus pi over 4, which gives you 2 pi over 4, which hence give you again pi over 2 as your argument there. So this is your final answer. So thank you very much for watching this video. Let me just emphasize on the question 2 and question 3. So you've seen how we've answered the last question here. I think this was question 6. We've seen how you've answered this question. That's the way you answer question 2 and 3 here. Question 2 and 3 there. The way you do them, so you convert them into a complex number, into polar form, and then you convert also the denominator into polar form to look something like this. But after converting them, immediately after converting them, you can now start doing the steps that I'm just from doing on question 6. So thank you very much for watching this video. Don't forget to subscribe to the channel, and if you have any questions and any contributions or corrections, you can send them to my WhatsApp line, which is this one here. Shalom.